So we're continuing with some examples on this work, and they're all getting a little bit more tricky now. Okay, so we've got this diagram here, and it's really a square pyramid. Sorry, it's not a square pyramid, it's a rectangular pyramid. So this base here is rectangular. Okay, now they haven't put the right angles in these four corners. Sometimes the book will do that. I'm not going to put them in, but let's just assume they are. So it is a rectangular base. All right, now we also have, I've drawn in the red dotted triangle and a blue dotted triangle. So if you use different colours, this will make it a little bit easier to see what's happening. So with the red one, we've got it going from the top point of the cone to the middle of the base shape. So right in the middle of this rectangle to the point, we've got that dotted line. Then we've got this one coming out here. Now, it's coming right into the middle of that side. Okay, so there's a point right in the middle of that side. It's coming straight up to there. And then the hypotenuse is going up that triangular sloping face. The blue one also has that height going from the top of the cone point to the middle of the base. And then this line comes to the middle of this side. And then we have its hypotenuse coming off this triangular sloping face. Okay, now in the questions we're continuing on from what we did in the last video. So part one was to find the perpendicular height of the pyramid, h. Now we can do it using the red triangle, if you have a look at it. So we've got we've got a red triangle there. It's right angled. So we're going to use Pythagoras Theorem. C squared equals a squared plus b squared. Concentrating on the red triangle, our hypotenuse is 68, so it's going in there. One side is h, and the other side is this one here, going from here to here. Now if you move that out, it's this. It's 32. So we're going to put 32 in there. We're going to go through Pythagoras' theorem and we will end up with a height of 60 millimetres. Now you could have used the blue triangle to do this as well. So if you wanted to, you could have used Pythagoras' theorem with the blue triangle because the red height there is part of the blue triangle as well. So you could have put it in and we would have had a hypotenuse of 61. H would have been one side and the other one would have been this one, which if you go straight over here is 11. And if you had have continued with that, you would have still got the same answer of 60 millimetres for the perpendicular height of the pyramid. Okay, in part two, we're finding the volume of the pyramid. So again, it's V equals a third AH. Our base shape is a rectangle, so we're putting LB in for A. And now we're going to put in all our numbers. So our length and our breadth of our rectangular base, our length will be 64. If you add the 32 and 32 together, our breadth will be 22. If you add together your 11 and your 11. And the perpendicular height, well, we just found that. That's why they asked us. So that's 60. And if you put it in the calculator, you're going to get that answer. Right, now the capacity. We're looking at what we got for our volume and trying to convert it to liquid measurements. Well, millimetres cubed really needs to change to centimetres cubed first because we know nothing about converting to liquids for millimetres cubed. It's too small. So we're going to go from here to here. We're going to a bigger unit, so we divide. And if you think of your ruler, there's 10 millimetres in a centimetre, so we're dividing by 10. That's cubed and that's cubed, so we put a cube there. So if you do 28,160 divided by 10 cubed, you will end up with this, 28.16 centimetres cubed. And then to convert from here to here, 1 centimetre cubed equals 1 millilitre. So the numbers don't change. So that many centimetres cubed will be the same number of millilitres, and that's your capacity. Okay, now the next question, we're looking at the area of the base of a pyramid. They've told you the area of the base shape already. It's 40. The volume is 360. We're trying to find its perpendicular height of the pyramid. So we're starting with the volume of a pyramid formula. Look for your words. That's your start. Then we're going to put in what we know. Our volume is 360. Our area of our base shape, we know what this piece is. It's 40. So we don't need to put any other formula in there. Okay, now this bit here, 1/3 times 40. If you use your calculator, it just gives you 40/3. So I'll just leave it like that. And we'll keep our 360 here. So now we have to get rid of times 40/3. So we're going to come over to the other side here. We're going to write our 360. And we're going to divide by 40/3. Now it's much easier with your calculator if you use the divided by for this. So just do 360 divided by, then press your fraction key, 40/3 equals, and it will give you the 27. Okay, otherwise you risk mucking up the fraction bars and what's happening with that. So when you start a fraction key, you would be putting the 360 in if you're going to do it using this way. Then when you down arrow, you actually start up a new fraction key. If you don't do it that way, you're going to get it wrong. Okay, so if you insist on doing it with all fraction keys, you can do it that way. All right, now in number 4, we're just calculating the volume correct to 1 decimal place of a cone. So a cone is a pyramid, so it's V equals 1/3 AH. It's a circular base, so we're putting the area of a circle in here, pi r squared. And now we're going to sub in. So it's 1/3 times pi times, the radius is 5 squared times the perpendicular height. They sometimes will write out there. They're trying to tell you what the height of the pyramid is. They sometimes write it out there. So that's what the calculator will give you, and we're rounding to 1 decimal place. So it's 209.4 metres cubed. All right, now in the next one, we're going to go through this. So we start off the same way, start off going into our formula, and then we hit a bit of a roadblock because we're going to do 1/3 times pi times the radius 4 squared times, and we then discover we have no perpendicular height. So let's draw in with your red pen your perpendicular height. Call it capital H, and we know that's what it's going in for, and that's what we have to find. So you can see the right angle triangle we're going to use Pythagoras Theorem for. So I'm coming over here to the side, and now I'm going to put my hypotenuse in, h squared plus the other side squared. Just rearrange this and it'll look like that. Okay, when we take the plus 4 squared to the other side, use your calculator and you're going to get 48. Then we're going to get rid of our squared by square rooting on the other side. And that's the decimal you end up with. Now, you're not going to do any early rounding on that. We're going to take that number into here. Right now, I know it's hard to fit it in and I've moved over a fair way, but we're going to keep it going here. 8,203,23. I'll just write it underneath there. If you had just worked that out, you keep that answer on your calculator. Okay, then when you come to doing this, when you get to there, you just go times answer button, ANS, and it'll bring that up. You won't have to type it in again. Then when you press equals, that's what you get. And we're rounding to 1 decimal place. So that will become 0.1 centimetres cubed. Okay, now we're coming over here to do a few other questions, and they are going to get hard in a minute. All right, this next one is asking you to leave your answer in terms of pi. Now what that means is they want pi in the answer. Pi must be in the answer. Okay, so we're going to start off with the same formula, put our pi r squared in for our area, and now start subbing in. We end up with an answer, we end up with that for our substitution. Now because we want pi to stay in the answer, do not just keep that out of your calculations. So what you're going to type in your calculator is 1/3 times 8 squared times 15. That will give you 320, and then we're just going to write the pi on the end. So you don't put the times pi in your calculator. Leave it out of the calculations. And then you can just write the centimetres cubed on the end. And see, we've got pi in our answer now, because we didn't put it in the calculator. All right, now number 6. I'll just move all of this over because we've got a few hard questions coming. All right, so let's have a look. You're still not going to be able to see it all, are you? Okay, we'll just go a bit further. All right, let's have a look now. So, okay, in number 6, it says a cone has a volume of 820 metres cubed and a perpendicular height of 10 metres. Find its radius correct to 1 decimal place. So the things you need to spot are volume and cone. That gives you your starting point for your formula. V equals a third AH. Put your pi r squared in for your circular base for a cone. Now we sub in what we know. The volume is 820. That goes in here. We also know the perpendicular height is 10. That goes in there. And all of this just stays as it is. All right, now, all you do when you're doing these, don't panic. The only thing you don't know there is R. So eventually we will get R out because it's the only thing we don't know. So when you go to your calculator, you're just going to do 1/3 times pi times 10. So you just leave out the bit where you still don't know, the R squared. Put everything else in. 1/3 times pi times 10. The calculator will give you that answer for that, and the R squared is just going to sit on the end. So now we've got a little equation to solve. So we're going to get rid of the times 10 point, all that decimal. So no early rounding. We come over here and we write the 820. The opposite of times is divide. Okay, the R squared's now staying here on the right hand side. Work that out and your calculator will give you that. Then we're going to get rid of our square by doing the square root on the other side. And that's the answer your calculator gives you. Now we can round it to 1 decimal place and that's it. All right, now this last question is tricky. And if you can get through the second part of this, you're doing really well. It is extension. It is a hard question. So I want you to write this down as a hard one. Now the first bit is going to be easy enough. The second part, a lot to do. All right, so a cone has a base radius of 20 centimetres and a perpendicular height of 48 centimetres. Find the volume of the cone. Let's go. V equals a third AH. Put your pi r squared in for A and let's sub in. 1/3 times pi times the radius is 20 squared times the perpendicular height, 48. Put it all in your calculator and I don't want any rounding. We've got centimetres cubed on the end. Now, they didn't ask for rounding, so we're just going to leave the answer. Now this next one is very tricky. Just stay with me. For those of everyone copies it down, have a look through it. Anything you can possibly understand, great. And those that you really want to persist with it, really listen to what I'm saying. Okay, so what we have here, and we're actually getting into something that's a big part of extension 2, which is the highest level you can do for your HSC. Okay, so let's have a look. We've got the top of the cone is removed at half its height. What are they talking about? Okay, so let's draw the actual cone we had before. Right, so we've got the big cone here that I've drawn in black. So remember that had a base radius of 20. I'll just leave the units out because it's just going to get in the way at the moment. So the base radius was 20 and it had a perpendicular height of 48. That's the big black cone there. Now, we're removing the top half of it at half its height. So if the height was 48, half of that height is 24. So we've got this little cone that I tried to draw in red. It's been covered up a little bit, but that's okay. So this little red cone at the top has a height of 24, right? Now, we are going to remove that. So, like you slice through it at this circle here and then throw it away. Now, what you're left with is this bottom piece here. It looks like this. Oops. Looks like a lampshade, doesn't it? All right, it's actually called a frustrum. Frustrum. All right, that's what you're left with. So we're removing the top, and that's what you're left with. Okay, so the removed piece, the little red cone at the top, that's what we're working out here. So we've got 1/3 pi r squared h. So we've got 1/3 times pi times, and then you hit a roadblock because we don't have a radius here. We don't have one. So we'll talk about that in a minute. We do have a height. We've got 24 for the height of the cone, but the radius, we don't know what it is. So what I've done is looked at a cross-section here of part of the diagram, and I've drawn it over here. So I want you to look at that black right-angled triangle there and the blue one sitting at the top. Now that's what I've drawn here. Now this involves putting all the stuff you've learnt from maths all together. Okay, so we're getting lots and lots of different things and putting them together now. So the really good mathematicians know how to connect all their topics. All right, so I'm drawing what I know. I know the height 48 for this big piece here. I know the top height there is 24. I know the base radius down there was 20. That's all the stuff I know. I don't know this. I might call this R actually. Let's get rid of that. Let's call it R because it is a radius. That's what we're trying to find, isn't it? I might call them all R's. Okay. So that's the radius we're trying to find. I'll fill this in a minute. Okay, so these angles here are actually equal, right? Because they're horizontal lines going through there. And two horizontal lines will be parallel to each other. So you've got parallel lines. Here's your transversal cutting through the parallel lines. I could extend these lines so you can see it a bit better. Right, if I extended these, you could see your parallel lines. There's the transversal cutting through. Now, I said alternate. They're not alternate, are they? What are they? What kind of angles are they? They're corresponding angles. They're forming an F. Okay, so you can see the F shape here. If we go around that angle and around that angle and join it in the middle, you've got an upside down F, upside down back to front F. Okay, that's corresponding angles when they form the F shape. So they're equal. So if we look at that equal angle and think about your tan ratios, the tan ratio is opposite over adjacent. So the tan of this theta is 24 over R. Okay, let's write it in. And the tan of this black one is 48 over 20. So these two things must equal each other because they're both equaling the tan of the same angle. So they must equal each other. So we have 24 over R equals 48 over 20. Now all I've done in that next line, probably didn't need to do it, but I did anyway, is I simplified 48 over 20 on the calculator and it gave me 12 over 5. Now I'm trying to find R. Well, it really is like equivalent fractions. So to go from 12 to 24, I times by 2. So let's do the same going this way. 5 times 2 is 10. So I have found the radius I need. So now I can come over and put that radius in there. Now if I work that out, I'm going to get that off your calculator. Okay? Now, the question itself said, what percentage of the cone remains? To find a percentage, you know you times by 100. And the other important word was remains. So in the beginning fraction here, the remaining bit is what goes to the top. Now, if you don't have any other important words, it's always the original thing on the bottom. So let's have a look. The part that remains is the whole volume of this cone minus the volume of the little cone. So that was the volume of the whole big cone. This is the volume of the little cone. So we're going to subtract those to find what remains. The original is the big one that we started with here, so that's going on the bottom, and then we're going to make it a percentage by timesing by 100. When you do all that on your calculator, you get a nice neat 87.5, and you write percent on the end. Okay, so you wouldn't have got that nice answer if you'd rounded any of these decimals off early, so no early rounding. So you can see we involved a bit of trig here with our tan ratios, we involved a bit of geometry with our corresponding angles, and we're actually doing a volume question. So there's 3 topics in one here, and that's what makes it hard. Okay, so I've done that hard question on the board, so you won't have to do it, but have a go at all the other questions for homework. Let me know if there's any problems.